Hello there, and welcome to the CSWatch OCR J276 video where we are going to be looking at von Neumann CPU architecture. We're going to be looking at what the von Neumann architecture is, how the architecture works, and some limitations of the architecture as well. Just a little bit of a history lesson for you. John von Neumann was a Hungarian computer scientist who came up with the idea and concept of von Neumann architecture, strangely enough, as you can tell by its name. He had the idea of having the control unit and ALU, like we've looked at in a previous video, and then also the idea and concept of having registers in there as well. So in the two sorts of registers which we have in von Neumann CPU architecture are the memory address register, or MAR, and the memory data register, MDR. And the MAR holds any memory address which is going to be used by the CPU. So straight away it will know any address, any location which is going to be used by the CPU during its cycles. The MDR actually holds the data and instructions. So the MAR is the address, the MDR is the actual data itself. The accumulator, which is part of the ALU, stores the results of the calculations. So any calculations, any bits of maths which happens, the accumulator stores it. And then the program counter inside the control unit holds the memory addresses of each cycle of the instructions. So if we have a look at this now I've added onto it the two registers, the accumulator and the program counter, you can see how it goes around. So the program counter can talk to the registers can talk to the accumulator can talk to the control unit, and vice versa. It can talk to each other as well. There's another form of architecture known as Harvard architecture, which isn't part of J276, but it's a nice little interesting tidbit to know. Von Neumann only uses one memory for data and instructions, whereas Harvard uses separate memory and separate memory for data and instructions. So von Neumann uses one, Harvard uses separate memory, and that's something we'll be looking at shortly. But when we're looking at von Neumann architecture, we've got the idea of the MAR holding any memory addresses which are about to be used. So that might be looking at an instruction or looking at data. The MDR holds the actual data instruction itself, so it might be fetched from memory, might be waiting to be written to memory or being read from memory. The accumulator stores all the results, all the calculations in the ALU, and then the program counter holds the memory address of the instruction for each cycle. And remember, with the CPU, this is an ongoing process, so all the time the MAR can be updating, the MDR can be updating, the accumulator is storing more information, and the program counter is looking at different memory addresses. So, how do they all interact together? The program counter starts off each cycle, so because that holds the memory address for each cycle. Once the PC's got the memory address, that passes information over to the MAR MDR, which then holds all the addresses being used. So it goes from the PC to the MAR MDR to get the information, and the accumulator does all the maths, and then it goes round on a cycle again. So it goes program counter to start off the cycle, the MDR and MAR get all the information, sends it to the accumulator, and then this loop just keeps repeating and running on and running on. Two main limitations to be aware of when we're looking at von Neumann architecture. The first one is bottlenecks, and I touched on it previously. Buses are used inside a CPU to ferry information along, and in a von Neumann architecture, the buses are shared. So straight away, if you've got lots of information waiting to get down on one bus, it's going to take time, so it's going to cause a bottleneck, or not all the data is going to go through straight away. Secondly, because how it works and how it operates, some code can self-modify, so it can make changes as it's being processed. This obviously is bad, because if it's going to self-modify, it can cause damage to itself. It could also even cause damage to the CPU as well. So in this video, we've been looking at von Neumann architecture, made famous by John von Neumann, the Hungarian computer scientist. Von Neumann architecture uses program counters, MDRs, MARs, and accumulators to process data in a cycle. These cycles constantly process data the entire time. As I've been recording this video, cycles on the CPU have been going around ridiculously quickly. There's limitations to it, but then again they can be mitigated. You can change the architecture to have more buses. You can change the architecture so the code doesn't self-modify. I hope this video has been helpful for you. I hope you feel happy now with the von Neumann architecture, and I shall see you in another video. See you later.